From that process of moving, we observed a pattern, which is called recursive pattern. So in order to find the least number of moves, first, we need to transfer n-1 disks to the peg B. If we illustrate into 3 and 4 disks, ganito siya. Next, transfer 1 disk left from a peg A to peg C. So it looks like this. Then finally, transfer n-1 from peg B to peg C. So yan yung napansin nating pattern. That's the process we need to follow in order to find the least number of moves. Now, let's try to transfer into mathematical formula. So let's start in 1 disk. For 1 disk, we have m of 1 or move of 1 is equal to 1. For 2 disks, we have move of 2 is equal to 3. And for 3 disks, if we transfer n-1 or the green and yellow disk to the middle peg, the number of moves is just like the moves we get in 2 disks. Then another 1 move if we transfer the large disk in the right peg. And if we transfer n-1 to the right peg, is just equal to the 2 disk. So, n is equal to 3, we have move of 3 is equal to 2 multiplied the move of 2 plus 1. So, b equal to 2 multiplied by 3 plus 1 is equal to 7. And for the 4 disk, if we transfer n-1 to the middle peg, it's just like the moves we get in 3 disks. Then, another move if we transfer the large disk to the right peg. And if we transfer n-1 to the right peg, it's just equal to 3 disks. So, n is equal to 4, we have move of 4 is equal to 2 multiplied the move of 3 plus 1 is equal to 2 multiplied by 7 plus 1 is equal to 15. And the recursive formula for that is m of n is equal to 2 multiplied by m, quantity of n-1 plus 1. If we continue to solve, this is the summary of least number of moves. But before we proceed, do you think we can find the least number of moves of 100 disks using recursive formula? How about the 1000 disks? Think about it. So the answer is yes. Of course, we can find it. But it is difficult to solve because in recursive formula, we need to know the moves of n-1. So if the n is 100, we need to know the moves of 99 disks. What if we didn't know? So it's very difficult to solve it. And for the last part of this video, we need to use mathematical induction. And we try to think a formula based on what we investigate, to the least number of moves from 1 to 9 disks. And that formula that we think, we try to prove using mathematical induction. And this will be the general formula to the least number of moves in any n disk. So using the least number of moves from 1 to 9 disks, ang nakamap nating formula is 2 raised to n-1. We notice the hypothesis. But how we get the hypothesis? So, as you can see, the difference of m of n are 2, 4, 8, 16, 32, 64, 128, and 256, which are equal to 2 raised to n, right? So, let's see the difference of 2 raised to n in m of n. So, 2 minus 1 is 1, 4 minus 3 is 1, and 8 minus 7 is 1, and so on. So, we notice that the difference is 1. So, we input minus 1 to the general formula. So, let's try to prove this for step 1. If n is equal to 1, let's see if we get the moves is equal to 1. So, we substitute it to the hypothesis. And we get m of 1 is equal to 1. So, it is correct. Our hypothesis works in n is equal to 1. Next, for the step 2, let us assume that n is equal to k it is true that m of k is equal to 2 raised to k minus 1. Then for the last step, show that for n is equal to k plus 1. 2 raised to k plus 1 minus 1 is equal to m of k plus 1. So we manipulate that m of k plus 1. So we change the n for recursive formula of k plus 1. So the m of k plus 1 is equal to 2 m of k plus 1 minus 1 plus 1. Then we cancel 1 minus 1 and the left are 2 m of k plus 1, and the value of m of k in step 2, we substitute it to the value of m of k in step 3. Then we manipulate it and we got 2 raised to 1 plus k minus 1 is equal to 2 k plus 1 minus 1, which are equal to the both side. And we conclude now that we find the least number of moves of any NDs using our formula 2 raised to n minus 1.